Hi and welcome back. In this video we're talking about dealing with errors. One of Python's core tenets is ask for forgiveness, not for permission. Now, I know how well this works with friends and family. Not so well, but it works fantastically in Python. Let's have a look at this piece of code here. We've got our car class and our garage class. And previously we looked at how we can check that we make sure that the car is an instance of type car. But let's imagine that we did not do that. And instead we did something that's pretty normal for the majority of programming languages, which is to just, when you add a car, just add the car. That's what the method does. And then we would of course use them like so. Ford equals a new garage, and then Fiesta is a new car. And then of course Ford.addCar, Fiesta. This is the normal usage for these two classes. Now, normally, if we wanted to make sure that we're only adding car objects to the garage, we could of course do this. If is instance car, then do this, else print, your car was not a car. Your car was not a car. Or you could potentially raise an error here. I'm sorry, this should be Fiesta, not car. This is a pretty typical structure of calling a function, in this case, the addCar function. And before you call the function, you check whether that's something you can do. Can I call this function? Yes. Then call it. And if not, say an error happened. This is really popular structure in a lot of programming languages where you ask for permission first, and then instead of for forgiveness. So here you're asking for permission to run the function with the data you've got. If you get it, because this matches, then you add the car. Otherwise, you say your car was not a car. Python suggests that in many cases our code can be made more readable by asking for forgiveness instead. So doing something like this. Instead of that, doing something like this. Try to call function. This is not real Python code, by the way. If failed, do something. Say that an error happened. So you can see this is slightly more concise because you don't have to check whether the function is okay to be called or not. Okay. So circling back to raising exceptions, we could go back to adding our isInstance here. If not isInstance car of car, then raise a type error. And I'm just going to copy the string back from my notes so I don't bore you typing it. So again, it's the same string as we had before. So Python suggests that this is better because now we only have to check whether the car is appropriate once inside the method, and everywhere else we can just call it. We can just do Ford.addCar Fiesta. Of course, an exception might happen, an error might happen. And by the way, error and exception are pretty much the same thing, okay? I started with Java a long time ago and they're called exceptions there. So an exception or an error might happen when you call this method. For example, if your car is not a car, it's a string. So what do we do? Well, we're going to try to run the code. We're going to try, and that's try with a colon. This must be indented because this is a block. And then we're going to have an except. So we're going to try to run this block of code, and if anything happens, an error gets raised by something inside this code, such as a type error, we're going to say print your car was not a car. Okay. Now what's going to happen is, again, we're going to try to run this code, and then we're going to accept. And the only error we're going to catch, so if a type error happens, we're going to print this out. If a different type of error happens, like a value error, that will not be caught. So here, let's see what happens when we run app.py. Remember, make sure to right-click app.py and run it. Now we get nothing, because of course the car was a car object. let's try adding a Fiesta here and run it again. Now we get this message saying your car was not a car. Cool. What happens if instead of a type error here, we raise a value error? Not the right error to raise, it should be a type error, but just for example, now we get this traceback. And that's because the only thing we caught was a type error in our accept. And what happens when that happens is that the error stops being raised up to the next level continuously, and instead it just dies here, and we get access to doing something when that error happens. It's really good to catch the errors on your user interface. In this case, this is our user interface, sort of. It doesn't have much of an interface. But so that, and you should catch them so that users don't ever see this. You don't want your users to see errors. However, you should not necessarily catch them when you are working on the code that users are not going to interact with directly. That way, if an error does happen anywhere in your code, your program is going to crash, and that's good while you are writing code. Once you share the program with your users, you don't want errors to be appearing, so you want to catch them, like so. Okay. So there are two benefits. One is that I think our code reads more nicely. We're going to do this. Oh, okay, if an error happened, we'll do that instead. We don't have to check whether we can run something. And the second thing is that our check is now here. So for example, if we wanted to add 2 cars before, we would have to have this if twice before we add each car. Now the if is in the add car function, and our code only needs this single line. So again, the syntax is this try except syntax. We try to do whatever is in the try block, and if an error happens, we jump to the except block. And we do so only for errors that match the one in the block, a type error. We can catch multiple errors by just adding another except block. Like so. Now, if there is a type error, this would run, and if there is a value error, that would run. This is particularly useful when you have multiple types of errors that could potentially be raised. Of course, here, it's unlikely that that's going to happen. Over the next few sections, we're going to make use of this try except syntax a lot. So, just something to keep in mind as we move forward. Try and except also have a final counterpart, which is called finally. The finally block runs every time. So, you're going to try to run this code here. If an error happens, you're going to run whatever code is in the appropriate block for the error, and at the end, you're always going to run the finally block, whether or not an error happened. So here you could, for example, print the garage now has Len Ford cars, for example. So again, except blocks may or may not run, finally always runs. So again, if we run this now, we get something weird happened because we raised the value error up here, and then we print out the garage has now 0 cars. Notice how we don't see a stack trace because the error has been silenced by the fact that we caught it. So in the next video, we're going to look at how we can not silence it. And that can also be quite useful, especially when you're developing. I'll see you on the next video.